Hi everyone, this video is on question 4 of exercise 9H, and we have the equation x squared plus 3xy squared minus y cubed is 9, and we want to find a tangent to the curve at the point 2, 1. Okay, in questions like this, we always differentiate the equation and find the gradient at that point, and then we find the equation of the tangent. The only difference here is that the equation is written implicitly, and what that means for us is that we need to differentiate this using implicit differentiation, and because that's here the best way to do this. So to find the derivative, first of all, x squared just differentiates to 2x, and for 3xy squared, remember we should use the product rule because we have two different here variables, and that's why we apply the product rule, because we have the independent and dependent variables here. So we can write down the first function, which is 3x times the derivative of the second function. So y squared differentiates to 2y, but we always write divide dx for the dependent term whenever we differentiate that. The next part is the derivative of the first function, 3x differentiates to 3, and times by the second function. Now we can differentiate minus y cubed, which differentiates to minus 3y squared. As always, divide dx is equal to 0 because 9 differentiates to 0. So now this is the derivative, but we can rearrange this and write divide dx in terms of x and y. So let's expand the bracket first. So 2x plus 6xy divide dx plus 3y squared minus 3y squared again divide dx is equal to 0. Take a factor of divide dx, and we get 6xy minus 3y squared. And let's rearrange this and move every other term to the other side. So minus 2x minus 3y squared. Now we have divide dx is equal to minus 2x minus 3y squared divided by 6xy minus 3y squared. So this is the derivative, and let's find the value of the gradient. So here the interesting thing is that if you look at the equation of the gradient, we have x and y, and that's just because the initial equation is written implicitly, and that's why in our derivative equation we get x and y, because usually we just get x and we substitute the x coordinate of the point to get the gradients, but in this case we have to substitute x and y coordinates because we have x and y. So x is 2, y is 1. So substituting this gives us so divide dx is equal to minus 2 times 2 minus 3, 6 times 2 times 1 minus 3 again is equal to minus 4 minus 7 divided by 12 minus 3. Sorry, here it's just minus 4 minus 3, not minus 7. Yes, and we get minus 7 over 9. So that's the gradient of the tangent. And now we can find the equation of the tangent by using the formula y minus y0 is equal to m times x minus x0. So y0 is the y coordinate, which is 1, m is the gradient, is minus 7 over 9, and x0 is 2. We can now rearrange this. Minus 7 over 9x plus 14 over 9, and finally y is equal to minus 7 over 9x plus 23 over 9. So this is the equation of the tangent. And yeah, so that's it for this video, and thank you for watching.